A quadratic factor function with leading coefficient -2 has a factor of x plus 3 minus 2i. Identify the coordinates of the vertex. Okay, weird. Let's focus in on this factor. If we know we have a factor at x plus 3 minus 2i, we must also have a factor at x plus 3 plus 2i. That's kind of hard to see, but remember that factors are always written in the form x minus the solution. So in this instance, our solution has to be -3 plus 2i, because if it's x minus that, if I distributed that negative, I would get x minus -3 is x plus 3, minus plus 2i is minus 2i. So x plus 3 minus 2i. Do you see that? So if a solution is -3 plus 2i, then I also have the conjugate, -3 minus 2i. Written as a factor, x minus -3 minus 2i is x plus 3 plus 2i. So I have that, x plus 3 minus 2i times x plus 3 plus 2i, but I know my leading coefficient is -2. So that has to represent my quadratic because of the linear factorization theorem. And now I just need to make this less gross. So multiply everything together. Again, since we are dealing with conjugates, so much stuff cancels out. Maybe you see the pattern in what cancels out. If not, just expand it and then cancel afterwards. So leave that -2, let that chill. X times x is x squared. X times 3 is 3x. X times 2i is a positive 2xi. Okay, next term. 3 times x is another 3x. 3 times 3 is a positive 9. 3 times 2i is 6i. Last term, -2 times x. -2i times x is -2xi. -2 times 3 is, I keep saying -2. -2i times 3 is -6i. And lastly, -2i times positive 2i is -4i squared. And all of this messiness is being multiplied by -2. But let's simplify this disgusting down as much as we can. X squared has no like terms, so that x squared is coming along for the ride. But 3x has another 3x to make a 6x. Positive 2xi cancels with a -2xi. Positive 6i cancels with a -6i. And we're left with a constant term of 9. And this -4i squared. But remember that I squared is -1, so that becomes a +4 right there to give us 9 plus 4 is +13. Boom, like that. And now I'm gonna say that let's write this as -2 times x squared plus 6x, boom, minus 26. I distributed the -2 to that last term to pull it out. And now I want to complete the square. So -2 times x plus 3 squared, half of that number, right? I still have my -26, but how do I adjust this? Well, 3 squared is 9, times -2 is -18. So I've adjusted this by subtracting 18. So I need to add 18 to balance it. So my final answer is -2 times x plus 3 squared. -26 plus 18 is going to be minus, what's the difference of 26 and 18? 8. Right? Am I being silly? I think it's 8. So I get my equation in vertex form. So I know that my vertex has the coordinates -3, comma, -8. But I want you to look at something real quick. Let's look at where this equation comes from our factored complex form. Let's let that -2 be out front and think about what this vertex form would be without it. It would be x plus 3 squared. Think about where that came from. Plus 4. Think about where the plus 4 came from. Silence. 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 Interesting. I wonder if that will always work. I don't know. Maybe you can figure it out. But you can always go the long way and expand and cancel. Because we found that our vertex is at -3, -8, and all it says to do is identify the coordinates of the vertex, which we have done.